with the University of Nebraska, Omaha, and University of Florida, USA. To give an experience of the real corporate world and understand the challenges that lies ahead, our students also get an opportunity to connect with industry professionals and self-made entrepreneur. Our exclusive placement cell has an excellent placement record. All this has brought us several accolades. We're ranked among the top 100 engineering institutes by NIRF, MHRD. We've been declared Best Private University of Himachal Pradesh by Dialogue India in 2018 for academics and infrastructure. We're also ranked first under category of value for money and third under the category of top private university in 2018 for offering value for money education by India Today. With a hygienic mess named Annapurna, well-furnished hostels with single and double rooms, mechanized laundry, 24/7 water supply, complete power backup, and Wi-Fi connectivity, we ensure that students feel at home while they're away from home. The overall growth in personality and confidence is taken care by conduct of debates, declamation contests, and a host of indoor and outdoor games. NCC Wing for Girls, and a vibrant youth club that organizes popular sports festival called Padakram, literally festival and cultural festival, which further heightens their energy levels. They're also encouraged to develop independence in thought and action, as well as trained to deploy appropriate technology paradigms for given tasks, explore new horizons, and lead teams to solve complex problems. With our learner-centric educational process, students are free to find their own paths and learn their way to limitless opportunities that awaits them. So be a part of JP University of Information Technology, Vagnakat, Himachal Pradesh to be the leaders in innovation, entrepreneurship, creativity, and management. Because this is where we engineer lifelong learners.
Very good morning to everyone. Good morning, Jagjit.
Good morning.
Thank you very much for joining well before the time. So,
good morning, Jagjit.
Good morning. Okay.
Let me officially begin. Good morning, Nilesh ji.
Good morning.
Yeah, good morning, everyone.
So I hope my screen is visible.
Yes, it is visible.
Yes. So we begin our webinar series on Green Talk with Experts, which is being conducted by the Civil Engineering Department, JP University of Information Technology, Vagnakat, in collaboration with Indian Green Building Council, Chandigarh chapter. So today we are here gathered for the first webinar session, which will be given by Mr. Priyank Jain on efficient rainwater harvesting technologies. So without further ado, let me first give a brief about the Civil Engineering Department at JP University. The department here prepares the students for award of BTech degree in civil engineering and a new curriculum which we have just started, that is civil engineering with computer applications. This curriculum has been specially designed to keep in view emerging civil engineering needs of the country, as well as the modern emphasis on the IT-enabled civil engineering. Department also provides at PG level 2 years MTech program in construction management, environmental engineering, and of course, in structural engineering. In addition to a PhD degree, which is offered in the areas of geotechnical engineering, structural engineering, construction management, hydropower engineering, environmental engineering, and water resources. With qualified faculty from institutes such as IIT's Pilani, we are here with a lot of civil engineering equipments also available. So this session on the Green Talks, let me give first invite to Mr. Jagjit Singh Majha, who is the co-chair of IGBC Chandigarh chapter, to give the inaugural address for these sessions. So, Jagjit sir, over to you.
Yeah. Good morning, everyone, especially the esteemed faculty, the professors, HOD, and my dear students. In fact, I've just seen the video of JP University, its contribution in building the nation, because youth is our nation's precious treasure, and they are contributing their best, even involving in extracurricular. Even we have seen that you have got NCC also. That's great. In fact, IGBC's contribution in making people aware about green movement and preserving the sustainable, precious uh, nature, and in making a sustainable growth is commendable. And I am proud that associated with this IGBC movement, and chapter is trying its best to contribute uh, to the sustainable development in India. In fact, I belong to realty sector. I am representing, in addition to IGBC's commitment to the society, I am associated with Confederation of Real Estate Developers Association of India. And the responsibility of builders and developers is more when we talk of this development. In fact, when we talk of sustainable development, so to preserve the natural resources is very important, and water is one of the essential commodities. And everyone knows that the importance of preserving the water is the need of hour. That is why we have most of us are committed to rainwater harvesting. My Karapumi is New Chandigarh. I am working in New Chandigarh. In my township, I have got 4 rainwater harvesting setups installed. And most of the developers are abiding by this. As everyone knows that climate change, reality, it's happening every day, and we are to be very particular in guiding our youth, the main force which is going to take act forward for preserving the environment and for preserving the essential communities like water. And rainwater harvesting is very important. Even not in townships, it is our commitment that in all our houses we take care of this rainwater harvesting. And since we are in Chandigarh, Chandigarh has made it mandatory for rainwater harvesting uh, systems to be installed in all. In fact, when we see the excellent efforts of IGBC, we are happy that at least one organization which is committed at the industrial level has taken the this responsibility on its shoulders, and we are contributing our best for this. IGBC has introduced grading system for promoting the awareness about green buildings and other parameters. And when we talk of grading systems, uh, we have got silver, gold, and platinum ratings depending upon the commitment of the project for the making of the sustainable growth. Several projects in our region have taken it very excellent steps, and are going that those are going for net zero energy and energy positive efforts. So when we talk of net zero, so as far as the water is concerned, because this is the main topic of today's webinar, zero water buildings are those that operate with the minimum uh, potable water consumption and sources that the balance water from alternative sources. Positive potable water, when we talk of, is the water which is available with us from municipal corporation or bore well or other natural resources. When we talk of alternative water, it is a rainwater is very important because it's a circulation of the existing water and getting it back for our routine uh, drinking purposes and other positive purposes. So rainwater, we have to concentrate on rainwater harvesting and promote it at so that the aim of achieving zero water is achieved in true spirit. So the other is that treated water, grey water, preferably this is used even in most of the projects we are using grey water for plantation purposes, for giving that other alternative than you can say the drinking water, because for drinking we need the pure water. But in foreign countries, in countries like Israel, the technology is best, and this gray water is treated for drinking purposes also. In India, it may take some time more to go for that kind of thing. Today the need is that as we are talking of, the emphasis should be on going for the alternative water where we can use it. Friends, going green and zero water, as we are discussing, it's a need of the hour. And the seminar will definitely add more to the awareness about how we can promote the rainwater harvesting at a zero level. I am associated with NGO also. It's a the punchline is my earth, my people, my word. So this kind of efforts, we see that the NGOs can play a major role in supporting the government and the word and management systems, the different governments, for promoting the cause of environment, water, and uh, achieving the sustainable development goals. When we talk of sustainable development, one aspect is very important. It's a new kind of effort. When we go for the traditional roads, we use a lot of aggregate. Since this university is in Himachal, so the natural sources are depleted mostly when we take that gutka and other things naturally available. So now it is a time when we are to switch on to looking at the sustainable development in roads. We have to switch on to steel slag. Steel slag is available in abundance. We are replacing it by natural aggregates. This is one of the positive moves and a new technology to preserve the natural resources. Uh, I must congratulate the team who is behind this webinar. We are part of it, and I wish this webinar the best to come, and a lot of things to happen practically. Good day, and I am with you to see the how the proceedings add to my knowledge and to the chapter and to the general masses awareness. Thank you.
Thank you so much, Majha. You have given a very wonderful theme to this whole webinar series. And as we are starting with first with rainwater harvesting, I'm sure in future sessions we will be covering various aspects as you highlighted, from materials to energy efficient buildings to policies. So all of these combine a collective effort we are trying to make here at JUIT with your group and Chandigarh with the IGBC. So these sessions will keep on going with this same enthusiasm. So now moving ahead to today's session. Today's session will be delivered by Mr. Priyank Jain. He is Director, Retas Enviro Solutions Private Limited, which is now around 7 years old company and has clientele listing from the most popular companies in India. Priyank has worked with several infrastructure companies previously, such as Majha's Ramki Infrastructure in the field of wastewater management and business development for 7 years before joining the team Retas. At Retas, he looks after project development, engineering and planning, business development and sales. He is an ex-IITian and he'll be delivering today's session on efficient rainwater harvesting technologies. So I invite now Mr. Priyank to take over the podium and begin with his proceedings.
Hi, Tanmay. Hi, Tanmay. Am I audible?
Yes.
Okay. Thank you, Tanmay. Thank you, Jagjit sir.
Thank you.
My dear students, Jagjit sir has almost covered the about the building, green buildings, what are the technologies are being adopted in green buildings and all. So today I will speak about the rainwater harvesting, its benefits, and what kind of technology you can adopt other than your conventional tanks. So I've just made a small presentation for you guys to understand about RWH. I'm just sharing it. Tanmay, give me 2 minutes.
You can just move to your PPT then. Once you do the whole screen, then just move to your PPT. We'll be able to see what you are seeing on your screen. Currently, you are muted.
It's coming now.
We are still waiting. You are at the correct screen previously. You have just pressed the stops presenting button. You just need to move from there, present now. And then,
I am doing present your entire screen, right?
Yeah, you can do that. After clicking on that, we'll be able to see what you are seeing on your desktop screens.
Yeah.
Now you are presenting. Yes, now your PPT is then. You can put in full. Maybe.
Is visible?
Yeah, now it's perfect.
Okay. So I have developed this entire content in 5 parts. So first we will introduce about rainwater harvesting. Second, we will go about the usage, advantages, and limitations of RWS systems. Third is system components and design consideration when you are designing for RWS systems in your projects. Then quality aspect of RWS system and examples of RWS systems. So this is a small about India, about the states where we are consuming the water more than its availability. If you look at the screen, Punjab is one of the highest state where they are using the water for irrigation more than the water available underground. Then we have Rajasthan, then we have Delhi, then Haryana, Tamil Nadu, UP, Gujarat, and MP. These all states are either agriculture states and they have industries as well, which are withdrawing a lot of water from the availability of underground water. Again, there is a story which you have seen a lot of newspapers being highlighting about India. Like we are facing very high stress, water stress in all the states. Whatever availability water is there versus our usage. Our usage is higher than what is available beneath the earth. So you can look at the small pie diagram where you will see irrigation is more because we India even today are called as an agriculture country. And for domestic and industrial, we are using 23% of water from the underground resources. The way we are divided into communities, religions, and other parameters, CGW has divided the entire country into 4 parts. One is called safe zone, one is called semi-critical zone, one is called critical zone, and then we are overexploited zone. So what is CGWA? CGWA is Central Groundwater Board Authority, which controls the water exploitation in the country. They have given many rules and regulations to the industries about water withdrawing and the water usage according to their demands. So what is safe? Safe means we have lot of water and 70% of water is available, more than 70% water is available for the usage to the consumers. And then what is the what they have to do if you are setting up an industry in safe zone, then you just have to adopt the RWH. Simple RWH you have to adopt for your entire facility. Then we have semi-critical states or semi-critical areas where if you want to put up an industry or if you want to use water, then you have to go for water audits, and 50% of recharge is made mandatory. It means, for example, if you use 100 liter of water per year or per month, then you have to recharge 50 liters of water per year or per month through your rooftop, through your paved area, through your green area, whatever you want to do. So you have to give back 50% of water to the Mother Earth. Then we have critical. Critical means whatever water you are withdrawing from the underground resources. For example, it is a X liter. Then you have to give double X liter of water to the Mother Earth. Then we come to overexploited zone. Overexploited zone means you cannot withdraw any kind of water from the underground resources. You have to be dependent on the municipal corporation water supply or other resources such as river water or something which is available near to your area. And you have to recharge 200% of the water of your usage. Is it clear?
Yeah, it's coming perfectly.
Yeah. Now introduction to RWH. So what is rainwater harvesting? It is a technology used for collecting and storing rainwater for human use. Human use means it can be potable as well as non-potable from your rooftop, from your land surfaces or any rock catchments. It is one of the most ancient water supply technology which has been practiced since our ancient ages. All the previous people were using rainwater in terms of babri. If you go to any fort or something, you will find a babri inside the fort for water storage. And then rainwater is an important water source in many areas where we do not have any kind of conventional or centralized supply system. If you see today, government is focusing on pipelines, water supply through pipelines. So now, where we do not have any kind of municipal pipelines or where there is a short of water, those areas can be dependent on rainwater for the collection of water. Again, we have rainwater is a good option in areas for fresh water. It could be supplemented as a pipe water, which I have explained, and it's a decentralized solution for everyone. So now, what type of rainwater harvesting we can do? First of all, we can collect the water from rooftops. It's a simple collection from rooftop. If you have a single house, any factory or industry, you can collect the water through your rooftops. Then we have ground catchments. Ground catchment means you have roads, you have paved areas in your area. From there, you can collect the water. Then we have rock catchments. So Himachal is one of the examples of rock catchment where we get water from the rocks. And then we have collection of storm water, roof water in urbanized catchment recharge. So collection of storm water is what? Suppose you are living in a society, right? So you have a drainage system or you have the paved area. That is called storm water. Any water which is other than the rooftop is called storm water in the urban areas. So now, rainwater harvesting you can use for two purposes. One is non-potable and one is potable. Non-potable means you can use rainwater mainly in urban areas for gardening, for flushing, for washing your clothes and cars and washing your house. These are all non-potable purposes. You can use the rainwater. In certain areas, in rural areas, generally people what they do, they collect the rainwater, they warm it and drink it. So after warming that water, they make it warm and then they drink. But it is not good for their health, which I will explain in the next slides. So that can be used for potability. Now, when people say, why can't we use the rainwater as a drinking water? So there are certain parameters which are being guided by Central Pollution Board of India and WHO guidelines with BIS standards. So there are 5 types of parameters which you have to achieve before drinking any water other than your treated water or any supply through the government. So one is organoleptic and physical parameters. Physical parameters, example is pH value, or maybe the color of the water. You can say order of the water. Okay. Second is toxic substance. Now, what is toxic substance? We have lot of hard metals in the water, such as mercury, cyanide, and all. So these are all toxic substances which are not allowed in the water. Then we have bacteriological quality of drinking water. E. coli is one of the bacteria which is generally found in the water. So when you are drinking that water, E. coli bacteria should not be the part of your drinking water. Then we have pesticide residue. What is pesticide residues? So when you use urea or other thing in your agriculture farms, the water gets percolated through the soil and it gets mixed with the water. So if you are collecting that water with the rainwater, then you will get pesticide residues, which you have to treat. Then we have some radioactive substances, for such as example alpha emitters, which you can go through your books, or in fact you can just go through the BS standards. You will get all the data of all this data. So unless until you do not meet these standards, you cannot convert rainwater into a drinking water for potable water for drinking purpose. Now these are the rainwater harvesting system and uses. So any water which is collected from the roof can be used for domestic consumption, and any water which is being collected from these ground catchments or any check dams and all, that can be used for livestock consumption. Your cow and buffaloes can drink that water. Any animal, they can drink that water. And maybe that water can be used for irrigation as well. And this is RWH in urban areas. In view of increasing migration to urban areas, the water requirement has been increased. And the emergence of mega cities in the next millennium, it is imperative the water supply system should be evolved to catch for such a development. Now, what is happening? Our cities are expanding in a larger way, and we need more water to consume other than availability. So, second option we have is either treated water or rainwater. In areas with relatively high rainfall spread throughout the year, so you can take an example as East India and South India as a Bangalore, where other resources of water are scarce, because Karnataka and maybe other states, you get rocks within the earth. So water availability is low and higher rainfall you have. There you can go for rainwater harvesting as a storage option. You can store the entire water and can use for your potable and non-potable usages. Now, installation RDO system mandatory for all the construction of buildings. As example, Jagjit sir already told in Chandigarh, it has been made mandatory. Even in Delhi, it is mandatory to make RDO systems in your facilities. Many government agencies are providing now subsidies. For example, Delhi Jal Board is giving 20% rebate on your water bills if you have a RWH facility in your home or in your facility or whatever campus you have. They are giving a rebate of 20% on water usage. I mean, the water which is being supplied through pipes. So, roof catchments. This is after the social economic level of population, which I've said, population is increasing, we are expanding, so we need a lot of water. Example of typical option in urban areas: rainwater used in household as a supplement. Public institutions such as hospitals, you have bus stands, roadway stands, and all other buildings. High-rise building in high-density urban areas. Collection of rainwater in industrial areas. Industrial areas, they can use for their process, or maybe they can use that water for their chillers and all as an industry. You can use the runoff in airports. As you have seen, the airports are big enough to collect a lot of storm water. That water can be used by the airports for all other meeting their secondary requirements. Collection of rainfall from public open spaces for recharging. Now, as we do not have much area for storage in case of cities in North India, there we recommend for recharge. The entire water you can collect and you can recharge that entire water to Mother Earth for the balancing of water, what you are consuming and what you are giving to Mother Earth. Now, what are the advantages of RWH in urban areas? First is flood control. A recent example you guys have seen must be Bangalore, where there was a heavy flood due to heavy rainfall. The reason was that there was no enough structures or no enough infrastructure where they can control the water and they can recharge the entire water which is coming through the storm drain line or through the roads or through the campuses. There are a lot of large campuses which do not have any kind of RWH systems. It will help you to replenish your depleting aquifers. Aquifers are what? Aquifers are the area which control the groundwater or which holds the groundwater, that are called aquifers. Stormwater drainage, then firefighting and disaster relief. These water can be used by the firefighting agencies as a underground storage tanks. It is one of the part of the water conservation. Then you can reduce the groundwater exploitation by using rainwater as a second option and financial savings. So instead of buying water tankers, you can use the rainwater for your secondary purposes. Now, when you design RWH systems, there are a few components and design consideration before you go for RWH. What are they? So first of all, you have to understand what is your catchment area. Like what is the roof size? I mean, the area of roof size can be huge, can be small, or whatever in terms of square meters, right? Then we have gutter and downpipes. According to the length and width of the entire roof, you have to decide the gutter size and the downpipe size from where the water will come after the rain. So then we have leaf screen and roof washers. What are these? Before every rainfall, every year, you have to wash your roof. That arrangement you have to do, and you have to segregate the water from the dust which is coming from the roof. What dust will come from the roof? Either it will be leaves or any ashes, deposition, or maybe the silt. So that you have to separate from the water before going into the storage tanks. Then the design of storage tanks. You need to calculate how much water I am going to store for my further usage. Accordingly, you can design the storage tank for your facility. Then conveying. Conveying means how you will direct the water through the gutters, downpipes, and the drainage system which you have in your facility. Like how many manual chambers you will design, what are the type of pipelines you are going to use, whether it is RCC or SDP, maybe PVC. So that you have to design as per the water conditions. And then water treatment. Water treatment means there are two types of treatments. One is pre-filtration, where you filter the water from all the coming silt, leaves, and other higher total dissolved solids, which is called TSS, total suspended solids, and TDS, total dissolved solids. After that, if you want to go for potable water or maybe for further usage, then you have to go for next treatment. Now, what are the factors we have to count for RWH system? One is the rainfall quantity. Every city has got their rainfall in mm, which means in meters per year. Like Delhi has got 760 mm per year. Chandigarh has got around 1100 mm per year. And likewise, every city has got rainfall in terms of mm per year. So this data you will get through the IMD website. There you will get entire rainfall data for all the states, for all the cities, for all the areas where you want to design the rainwater system. Then rainfall pattern. This is very important. Due to climatic changes, now what is happening? Rainfall has now, I mean, you can face the rainfall even in the monsoon season, or sometimes we also get the rains in the winter and summer season. So accordingly, you have to understand the storage of water, because if your water is having storage tank is having water for next 4 months, and then again you get the rainfall in winters, then where you will take that water. So likewise, you have to arrange for your all the systems. You have to think what kind of system I am going to adopt and for how many days. Then what is the collection surface area? Collection surface area means the area which is available for storm water. The roof is one of the example. Second is paved area in the green area. Then we have runoff coefficient of collection. What is runoff? Runoff is guided by the CGWA. The runoff means the quantity of water which you will get through your dedicated areas. Then storage capacity, daily consumption rates, number of users, cost, and alternative water resources. So these are the rooftops and runoff coefficient you can see. For example, if we use GI sheets for any factory or for any industrial establishment, 90% of water you will get through your roof. It is called runoff coefficient. So 0.9 means 90% of water will come through your roof. 10% of water will be a water loss either through evaporation or maybe some other leakages. If it is a tiled rooftop, then you will get 0.6 to 0.9. If it is asbestos sheets, then you will get 0.8 to 0.9, means 80 to 90% of water. And if it is an organic thatch, which means green area, so you will get only 20% of water. Other water either will be soaked away by the green grasses and all, or it will be runoff. So these are the runoff coefficient. You can get this data on all the websites of CJWA. Now, so after getting all this data, you will be able to understand how much water I am getting, what is the storage I have to do, what kind of recharge I have to do. Now, other than storage, when you come for RWS recharge, it means when you are giving the water to the Mother Earth, it is very, very essential to go for a vertical activity test. Why? Why for VS study? So all of us do not know where we are standing, what do we have beneath the earth. We are not sure what kind of soil we have, what kind of strata we have, and what we are going to have when you go for a bore well. So now VS study is being done to understand few points which I am explaining to you. To understand the depth of groundwater table. For example, when you go for any recharge, you cannot directly inject the water up to the groundwater. It has to be 10 meters or maybe 5 meters above the groundwater table. So it is very, very necessary to understand the depth of groundwater table while designing for a recharge system. Then to determine the depth of a bedrock or overburden thickness. So what happens? You have the water table. Then after certain water table, certain depth, you get beds of rocks beds, which are called echotards. So that we need to understand where we are getting the bedrocks. And after that, you have a confined aquifer. Before that, that is called unconfined aquifer. Okay. Then to determine the map stratigraphy, it means where we should go for recharge. Suppose if you have an entire land of maybe 30 acres or 40 acres, then we should be able to understand where we will get the better recharge rates, or what are the points where we should go for rainwater harvesting with the recharge bores. Then to determine the max clay aqueducts. Clay aqueducts is nothing. Clay doesn't. What is clay? Clay. What the purpose of clay is only. Clay do not allow the permeability, but it is porous. So what it will do when you do a recharge, if it is on the clay, then it will absorb the water, but it will not allow water to permeate. It will not allow the water to disperse at the other sources to disperse at the large extent. So that is why it is very important to understand the clay aqueducts. To determine the vertical extent of certain types of soil and groundwater construction is simple, and to determine the soil strata, which I have told. And in fact, this study will also help you if you are want to extract that water. Then at what levels your pump should be installed to take out the water, and at what distance, and how many bores can be developed for the extraction of water. This is one of the sample report which you can see on your screen. Like when you go for VS study, so you get the data. If you look at the front part, depth in meters is 3, 6, 12, 15, 20, 25, 80 meters. And you have the strata of the soil. For example, we have sandy soil, we have sand concord, we have concord clay, we have concord clay. So whatever you will going to face beneath the earth, you will get entire data for the designing of the RWS system or designing of the recharge bore well. Okay. Now, this drawing is very common, and all of you must have seen this drawing. These are called the drawings for the conventional structures, where they do nothing. So it's a simple structure of brickwork or RCC chamber, where we put in the filtration media of boulders, pebbles, sand, and gravel, and then we have a recharge bore well. So this system you can see at most places. These are called all conventional structures, which are being used previously by all the architects and the builders. Now the pain points of conventional structures. you will face lot of lot of people say ki our RWS system is not working or our water is not percolating through the RWS plates. So what are the pain points? You have to understand why they are not working. First of all, the construction time is very high when you go for RCC structures on any brick structures. It involves a large amount of manpower because you need a lot of manpower to for the construction of any RCC tanks and all. Use of material disturbing the nature ecosystem. The pebbles which are being sourced from the river, now there is the unavailability of pebbles, and in fact government has also restricted the use of pebbles. Pebbles were used earlier because they are one of the best filtration media for filtering the water and for cleaning the water. So this is one of the system why now we are not encouraging, or people are, in fact, the architects and consultants are not encouraging your conventional tank due to the lack of the natural resources, which pebble is one of the example. And then sand mining is also now being banned, so you will not get sand easily for your structure. And then you have gravels, so all are natural resources. Then there is regular and tedious maintenance, because once they get choked or blocked, you have to take out the entire media, you have to wash it and then again place it in the RWS tanks. It is a tedious job. Resources are getting expensive every day as well as labor, so costs are increasing every day. Manuals, the opening manuals which you have on the top are not safe, and we have seen a lot of incidents where some children have fallen down or maybe labor has fallen down, and there are gases which comes out from the all the manuals after opening certain intervals. Quality work is not ensured because however contractor is working on the quality, it is not being ensured. Space utilization, yes, you have to give the entire space or your gain area for the construction. Effective detention volume are not maintained. I will explain later. Aesthetically not accepted on the green paths or children's play area. So these are one of the drawbacks of the conventional tanks. This is the status which you can see after certain, after years of construction, because there is no pre-filtration. You get entire waste, polythenes and everything with the water, and it is stored. So what is next? So what we should do? So we at Retas, we introduced the ray-based tanks. These are all underground tanks which can replace the RCC tanks or brick structures. These tanks are made up of recycled plastic. So one way we are solving the issue of plastic, we are using the recycled plastic for the development of these plates, and we are consuming water. So आप बोल सकते हैं कि एक तीर से दो निशाने, प्लास्टिक का यूसेज भी खत्म हो रहा है और पानी का कंजर्वेशन भी हो रहा है. So these are made up of recycled plastic, honeycomb structure in nature. These are all closed loop, easy to install, lightweight, and qualify for green ratings. These tanks are used in all the green buildings for the points. You get the points for rainwater harvesting as well as using the recycled material for your usage. It ensures the water percolation from all the sides, which I will share in next slide. How? See, so these are the underground tanks. The yellow part is the soil, and this blue part is the tank with water. So water is percolating from all the sides of the tank. Either side of tank and from the downside as well. So three sides percolation. In conventional tank, the water only percolates through the bore and the downward. There is no side percolation. How does the technology work? So water is coming through the rooftop or the paved area, which you can call as a storm water. Then you have got a sedimentation chamber, which is for desilting chamber. This is to ensure to cut down the turbidity of water and the settling of all the solids which are coming with the water. All the solid means is TSS, total suspended solids, or other solids such as it can be a silt, It can be your plastic bottles, or whatever. I mean, people are throwing on the roads. Everything is coming with the water, storm water. Then we have a distillation chamber and oil trap. Because the water coming from the roads, it always contains the oil, lubricants, which are being dumped by the vehicles. So we have to use the oil pads and then distilling chamber. Then we have a filter, which is of SS mesh. So entire water is being treated here itself as a pre-filtration stage, and then water goes to the tank. So in tank, you're getting the clear water, and when it goes to the tank through recharge board, it goes to the mother. So you can see this example. It's a typical drawing in terms of water tanks. Sorry. Now this is the comparison of modular tank versus conventional. So what is happening? Your water is coming into the conventional tank. There also we have a distilling chamber, and then from the distilling chamber it is going to the conventional tank. Now conventional tank has the filtration media of sand, gravel, and boulder pebbles, which you call. The problem is, so for example, the effective tank capacity is only the blue part. This is the only tank capacity which can hold the water. And above it is the total freeboard area, because your downpipe or maybe your pipe which is getting the storm water is below the ground of 1 meter. So that entire area is of no use. It is an extra cost to everyone, and it is of no use. So tank capacity is only this blue bar and nothing else. Now what is happening in modular? Your water is being given to the distilling chamber. Water is being treated here. Then we have a filter. We have the patent filters which pre-filters the water, and then water directly goes to the tank. This entire green patch you can see, this is a soil. So I need not to go for any freeboard area, or I do not have to go for any kind of structure. Nothing I have to go. It's a simple tank which is holding the water, and the water is being perforated through the recharge borewell. So this is a small video I have enclosed. You can go through this video. I'm just playing it, so you will understand how these tanks are being made, being stored at the sites. Is it working, Tanmay?
It's working, but there's no audio to it. You can
Just
maybe
wait.
explain picture by picture.
No, just wait. It will come. Okay, I will do it. No problem. Okay.
Audio is still not there. You can just explain what's happening.
Yeah. So I have told you about the. Yeah. So initially I told you about the BES study. This is a study which we do at the sites. So these are done through the conductivity through the electrodes which are being earthen in the earth, and then we get the results. Then we have the recharge borewell. Like this, we do the borewell and gravel filling for the time. Then we do a simple excavation. No brickwork, no RCC work. Then we prepare a base with the aggregate and the sand, which is also a natural resource. Like this, it is being compacted totally. No bricks, no RCC, no cement, nothing is required in this case. Then we have a layer of geotextile. You must have seen these geotextile are being used in the roads, on the road development these days. So what it does? It holds the entire load of soil, and it does not allow any soil to go into the tank. And these are the plates which are being manufactured using the recycled plastic, which is polypropylene, I will call it. Like this, we make the tanks at the site itself. So you can, as per the area available, like we have area length, width, whatever area is available, we can design the tank as per the area availability. We can go in length, we can go in depth, we can go in breadth, and whatever you want to do. So this is the tank is being installed at the site, and now we will wrap this entire tank with the geotextile. Your tank is ready for rainwater harvesting. Then we put a layer of sand just to distribute the load, even load on the tank from all the sides. And these are the filters where we filter the water, and your site is ready. So this your site is ready. You can develop whatever you want to do. You can make it a lawn, road, whatever you want to do, you can do it. You can use an entire area for your next purpose like this. Nothing invisible. Okay. So these are the advantage of the clips which we install in the tanks. It secures the tank, dent and weight, ties everything each other. Allows the installer to do the tank after installation and allows you to walk over the tank for checking purpose. These tanks can be used for recharge tank, percolation tank, and rainwater storage tanks. All any kind of RWH you want to do, you can use these tanks. So when you go for storage tanks, we use the sheet of liner after the sheet of geotextile. So this is being sandwiched between the layers of geotextile, and then we can convert this tank into the storage tank for water storage. So like this, these tanks are being stored like this. This is a driveway, the tank beneath the driveway. This is the tank beneath the lawns. This is a simple case study which we have done for one of the client. The only reason was why we were cheaper than the conventional tanks. Because if you can see the depth of the tank, we had only 1.31 meters, and the depth of the tank of the client was 5.31 meters. So they had a lot of costing of structural drawings. I mean, on the structure part, they were very costly. So they opted for the modular RWS. These are the another way of RWH. Even today, a lot of people in Rajasthan, in Tamil Nadu, Karnataka, they go for pond development. This is one of the best source for RWH, where we have the areas for recharge. We have number of areas. So this pond, you can see, this pond has been developed, and now all the livestock are having their water from the pond itself. This is one of the pond we have done in Rajasthan. We have recharge bore wells. So what will happen? The water will come to this structure, it will recharge, and then overflow of the water will go to the pond. So these are one of the examples of pond development. This is that.
So thank you once again, Priyank, for this very wonderful presentation, and given from the very basics of it, and so that our students and faculty around can be involved in it. The presentation very nicely explained the concept, how the rainwater harvesting is being done, and what you have done, your new innovations to it. So thank you for a wonderful presentation. There are a few questions from our participant side. So one of the question is Phytoid technology suitable for rainwater harvesting? Phytoid.
Phytoremediation.
It is for wastewater, not for RWH.
Yeah. So can it be treated and then it can be developed for this same?
No, what can be treated?
As for Phytoid is they are doing for wastewater.
So see, any water can be used for anything. The only thing is you have to meet the standards of BIS and the CPCB and WHO if you want to go for drinking purpose. If you want to go for another purpose such as irrigation or maybe landscaping or what, then you have to go for the ultrafiltration or maybe UV. You can use and you can purify that water and use it. That's not a problem. All the guidelines are being given by all the departments.
Correct. One other question is regarding the suitable climate, arid or semi-arid or humid, for where RWH is more suitable?
See, RWH is suitable for all the places. Wherever you are getting the rainfall, you collect that water. Even in Rajasthan, people are using the RWH since ancient times. They are using babris. So in all the areas, you can use the rainwater. You have to collect it, then you have to just think for it how you are going to use it. Either for recharge. For example, in North India, we go for recharge. We do not store the water. Or the rains are very less. In South India, if you talk about like Chennai, maybe Bangalore, Kerala, you have lot of rainfalls, and their water storage is the key requirement because aquifer is very low and the water availability in the ground is low. So therefore, people in South India generally go for storage tanks always.
Correct. So, are there any questions from audience still? One question is regarding the technical info. You can directly contact maybe at Retas, Ajay, you have asked. Yeah. So you will be able to contact Mr. Priyank. I'll share those details with you regarding the technical info, how these modular can be installed. So what is the story behind how did you come up with these modified or modular techniques? Are these a standard norm in other countries also to make these modular chambers?
So other than India, these technologies were being adopted by the European, US, Australia, everywhere.
Okay.
See, what is happening, Tanmay, now we all, as a construction industry, a lot of innovative technologies are coming up. We do not want to use any kind of natural resources. For example, now you have seen PEV building, steel structures, a lot of things are coming up. So we are trying to avoid the use of natural resources, right? And I mean, all the European countries and US and all, they have adopted it earlier. They are much ahead of us.
So the patent portion in this is yours regarding the filters, the filtration medium which you are providing. That is a unique selling.
That is our patented product because we have developed a filter as a pre-filtration part where we can remove all the TSS, TDS, and whatever dissolved solids are there, we can remove them.
Okay, so around what range of water you are getting if we are just quantifying how the water is having water quality after getting treated?
So see, when we connected, when we were testing our filter, so we were having TSS of 6,000 mg per liter, okay? And when we crossed through our filtration system, it was only 600. And now we are trying to get it up to 100 or 50 maximum, not more than that.
Yeah, that will become potable then. The same filtration medium.
Not potable, but you can use for. We can convert this water into potable. That's not a big story. But the only problem is BIS standards are very stringent, and achieving that level is actually a master job. But it will take time. We can do it.
Yeah. So, and you have certain solutions for hilly states like us also?
Yes, of course. I mean,
because we always have a sloped roof system over here. We don't have like directly duct, and then there are challenges. You don't get soily mass as you are getting in.
In Himachal, we do not go for any kind of recharge. The reason I will tell you why. See, all the rocks are there, right? And rocks are on each other. So what happens? There is a term called weathering. Okay. For example, if you have done a recharge in Himachal, right? What happens is when water will come into contact with these rocks, they will start getting weathering. Weathering means they will lose their own right condition, and they will start getting
decay.
Decay. So and it will fall. So आपने देखा होगा कि कभी भी पहाड़ गिर जाते हैं, पत्थर गिर जाते हैं पहाड़ों में, वो यही होता है. जो rocks.
That's the internal seepage, and then that to internal pore pressure getting developed, they causes landslides. But here, what happens here in summer's times, a location like Shimla gets a severe water scarcity, and we are working with some government bodies here also to restore our lakes. So in these restoring techniques, as you are saying, one of the lakes you had in Rajasthan, we are just providing a borewell system, I guess. And then through that borewell, we are trying to collect the nearby filtration media. Is there any innovative technique which has come up for hilly regions also? Because here is a lot of water goes through the slopes and it gets wasted into the valley. So if you have certain ideas over it.
You have to just you have to find out that those pores that water is coming from the mountain, and you have to trap that water and go for a storage. The only option in the mountains are the storage tanks and nothing else. You can go for a storage tanks, nothing else.
Yeah, so this kind of modular design, if it has to work, we won't be able to dig it very easily. Like for industries, you are able to dig the soil maybe 1.5 meters.
That is why the best part of us is We don't want to go deeper. I mean, if we get a space of 2.5 or 3 meters, that is more than enough to solve the tank.
Okay.
And I think 2.5 is achievable in Himachal. 2.5, 3
Yeah.
meters.
2.5
Soil
to 3
actually.
meters. Yeah, and then your panels are very good looking. They can just directly connect any unskilled labor can also collect, and even there is no structural requirement. So that's a great portion about it.
Yeah, absolutely. In fact, it is very helpful in the mountains. I mean, hilly areas.
Yeah.
I've seen the labor working there.
Yeah. There's one more comment from Yash that plastic is harmful for water. Then also we are using plastic or e-plastic for making these tanks. Any comment on that?
This is a recycled plastic. It's a third grade. It won't affect any water. So virgin plastic affects the water. It's a recycled plastic. That is what I'm saying. I'm repeatedly saying it is recycled plastic. It is a polypropylene. Tested. It won't affect the quality of water.
Okay. One more question is, why implementation of RWH in all parts of India is being lagged or it's lagging? What can be the cause of the same?
See, it's a good question. If I say, RWH is a very negligible subject in India even today. But now people are focusing because a lot of young people are coming as an architect, as the contractors. So they are now interested. And the government also has pushed everyone to conserve water. I mean, we are seeing Mr. Modi always speaking about the water conservation. Now people are going towards it. But previously, it was totally a negligible subject. But it was a least priority. Okay, we will see it. और पहले क्या होता था कि कोई भी बोरवेल वाला आया उसको बोला कि यार एक बोरवेल कर दो हमारा काम तो हो गया आरडब्ल्यूएच का तो आपने देखा होगा छोटा सा एक बनाया स्ट्रक्चर उसमें बोर कर दिया उनके लिए बस वही है they do not understand the quantum of water which you are getting where you will store that water so for that water you take the tank then only it will recharge ना वो concept तो कभी रहा ही नहीं ना अपना तो सिंपल है कि बोर कर दो हो गया जी रेन वाटर हार्वेस्टिंग एक्चुअली वो concept ही नहीं है it's totally different now पहले लोग इनफैक्ट डिजाइन करते रहे 1 एकड़ में 1 पेट अब वो भी खत्म हो गया अब इट इज अबाउट द रूफ टॉप इट इज अबाउट द एरिया यू हैव एज ए रूफ एज अ पेव एज ए ग्रीन यू डिवाइड वाटर एंड देन मेक इट तो वो 1 एकड़ का सिस्टम भी खत्म हो गया
The same thing is asked maybe in one more question. In typical urban areas, in a plot of 30 to 30 cross 40 foot size, where is the space available for rainwater harvesting?
This was saying it's a home actually, right?
Yeah.
Home. See, homes and all in India right now are not in position to harvest the water. What you can store that water in a small sump you can make in front of your house and use it for your car washing or whatever you can do. At least you will be able to save 100 liters of water, 200 liters of water. If everyone does the same, then you can, everyone does the same in the colony, you would be end up in saving around 1 lakh liters of water.
Yeah. So at the colony level, it can be developed at a mass level, at the planning level itself. Infrastructure planning can be that. One more question is that in RWH, when you do it, will it increase water level of specific plot or neighboring areas also? Then budget should be borne by individual or by together as a builder. The question is that to increase in RWH system, when you do it, will it increase water level of specific plot or neighboring areas also? And then the second part of the question is, then the budget should be borne by individual or it should be a combined kind of budget?
First of all, I will just tell you, you cannot work on ROI. The reason being what happens, when you recharge water, so you have aquifer and you also do not know where the water is going and from where you are getting the water. It's a huge study. So it is not necessary that whatever you are recharging in your plot, it will help you. It can help other people as well. Water will go anywhere, where it will get so you cannot work on that ROI thing कि मेरा पानी तो मुझे मिलना चाहिए वो नहीं हो सकता. It's not possible. It is for everyone because you are also getting water of the other people. You are not generating it.
Sure.
How can you say it's my water? You are getting other water, so it will give to everyone. That's the thing.
Yeah. Second part was regarding the budgeting or who should borne the price of this, who should bear the price individually or combined.
नहीं देखिए अभी तो मतलब commercially तो अभी जो भी industry चलाती है they pay for it. So because it's a norm for them, so they have to recharge the water or they have to store the water.
Yeah.
It's a totally on them.
Yeah.
But yes, we have tied up with few NGOs. We are doing some kind of things for the छोटे-छोटे गांव villages में हम लोग लगाए. We are helping them.
Oh, that's great. So I guess with these, we have exceeded our time limit also. So we once again thanks Priyank for giving us such valuable time and giving such a valuable talk for all of us and giving a motivation that we should work in this direction. We are once again thank Jagjit Singh ji to give his whole time and listen to the whole discussion very patiently and giving his valuable session address. To Nilesh ji to organize this event with us at JUIT, and all of my colleagues and my students and the members which are coming from all around the world to help us in this webinar series. So this webinar series will go on in periodic fashion. Maybe in each 15 days, we'll give you an intimation, and we will have such distinguished speakers with us, and certain various aspects in green building design we will cover in this series. Your valuable suggestions are always invited. We have circulated a feedback link. We will again circulate it. So you can please put your feedback over there. How can we more effectively do these webinar sessions? And with this, we close this session for today. We once again thank all of you. Thank
Thank
you.
you so much. Thank you, sir.
Thank you,
sir.
Priyank ji. Thank you, Jagjit ji.
Really.
Bye. 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 Thank you.